In this video, we're going to talk about the vertical line test. In the previous video, we mentioned about how some equations can define y as a function of x, right? And we kind of looked at those things algebraically. The vertical line test is just a way to look at that same issue by looking at the graphs of the equations involved. Okay. So it's really the same topic. It's just looking at it in terms of the graph. So first off, the statement of the vertical line test, right? An equation involving the variables x and y defines y as a function of x if every vertical line intersects the graph of the equation in at most one point. Okay, so if I have a vertical line, right, then I can take a look at the graph of the function, and that vertical line may or may not intersect the graph, right? If it doesn't intersect the graph, that's fine, right? There's no issue there, right? But if it does intersect the graph, it needs to do it in at most one point. So 1 point's fine, no points are fine. But the minute a vertical line intersects the graph in 2 or more spots, then that graph, right, the graph of that equation fails the vertical line test, and that equation will not define y as a function of x. Okay. All right, let's take a look at the graphs. All right, so in our first example, we are going to look at the graph of x squared plus y squared equals 1, right? We already know that from doing the algebra in the previous video, right, that this does not define y as a function of x, right? It didn't pass at 0, right? When I plugged in 0, I got 2 solutions. Or if I looked at it in terms of the two different functions or solutions that I got for y, right, I got 2 different ones. So now let's look at it in terms of the vertical line test, right? Here's the blue vertical line that I'm moving around, and I can see over here, right, there is no graph of the function. And so the vertical line test, that's fine. The vertical line doesn't intersect anything at all. If I put it right here at the vertical line at 1, right, I can see that the vertical line does intersect the graph right here at this point, 1, 0, so that's fine, right? But the minute I move it anywhere over here to the left, right, I'm going to get 2 intersection points of the vertical line. So right there, that tells you that the graph here does not pass the vertical line test. So in other words, this equation does not represent y as a function of x. And in particular, right, remember in the previous video we tried the point 0, right here. When we plugged in 0 into this and solved, we got 2 solutions, y equals 1. So you can see that's the y point of this intersection point. And over here, y equals -1, that's the y point of this intersection point. So if you plug in a value and you solve and you get multiple points, multiple solutions for y, right? What that will mean is that any vertical line will intersect that graph in those points determined by the x value that you plugged in and the y values that you got out. So if you get more than one y value as a solution, right, that means in the vertical line test it's going to pass through those 2 points. So this equation, x squared plus y squared equals 1, doesn't pass the vertical line test, and so therefore it does not define y as a function of x, which we already knew pretty much anyway. All right, let's take a look at the next example. In the next example, we have this equation, 2x plus 3y equals 1, and we could know that we could pretty easily solve that one for y, right? And if you look at the vertical line test, right, the graph of the purple equation there is just a line, and so this vertical line is going to intersect it in exactly one spot. No matter where I slide that vertical line around, it's going to intersect it in exactly one spot. So this equation does pass the vertical line test, and it is, as an equation, right, it does represent y as a function of x. And in fact, it wouldn't be really hard at all to solve for y here, okay, and get that result algebraically as well. All right. Example 3 is this equation that we mentioned in the last video. Um, you can see already right here, it doesn't pass the vertical line test. There are 3 different spots at which I will get an intersection point of the vertical line, and in general, right, this is a pretty complicated looking graph. If you start sliding out here, you will get a bunch of points over here, right? And so it's a pretty complicated graph. I said I put this as a representative one that would be difficult or impossible, right, to solve explicitly. So there's a look at the graph of that, and that one definitely does not define y as a function of x. All right, now the last example, in example 4 right here, if you remember when we, in the previous video, when we looked at x squared plus y squared equals 1 and algebraically asked, or we asked, does this equation define y as a function of x? We solved algebraically for y, right? And what we got were this function right here, y equals the square root of 1 minus x squared, and this one, y equals negative 1 square root 1 minus x squared. So right now you are looking at the graph of y equals square root 1 minus x squared, and you can see that that does pass the vertical line test, right? Every vertical line, right, will intersect that graph in at most one point. Over here it doesn't intersect, that's fine, and anywhere in here, right, it does intersect the graph. And but it only does it in one spot, right? Because that's what the graph of this function looks like. So that does determine y as a function of x, and in fact, right, you can see that it is in one of the ways that we specify functions. Y equals, and then over here is nothing but x's. So if I look at this one, it also does define y as a function of x right here. And it is sort of the bottom half of the circle here, and so it passes the vertical line test. This does define y as a function of x, and in fact you can see it, right, it's in that format right here. All right, so this is a really important thing to understand here, and we'll talk about this in the next video. Is that okay, we found early on, right, that this equation does not define y as a function of x, right? So that is by that, right, what we mean is globally. If I look at this entire equation here, the entire graph of the equation, then this will not work. It's not a function here. Y is not a function of x if I include the entire graph. But, right, if we are careful about it, we can carve out little pieces, right, of the graph. So in other words, here I'm just looking at the top half of the equation, or in this one, I'm looking at the bottom half of an equation. So the way I kind of like to think about that is that, okay, yes, an equation may not globally, right, if I look at the entire graph, so globally it may not define y as a function of x, right, but under certain circumstances there are little pieces of it, right, in this case the top half, and in this case the bottom half, which do define y as a function of x. So that's extremely important in the next video, and we'll talk about these little functions here that are defined in pieces of by pieces of the graph of an equation.